Here I will going on the fine structure of hydrogen. Fine structure hydrogen can be composed at a relativistic correction by electron velocity, because this fine structure constant is order of the V of C, that is corresponding to the 1 over 137. So it is kind of the 1% of speed of light. So we do not ignore this relativistic effect. And second thing is that the spin of coupling, and it is an interaction between electron spin s and orbital angular momentum. Orbital angular momentum L. Here I first review on the relativistic correction. Exact calculation can be viewed from the Dirac equation, but here I will start the relativistic kinetic energy and the rest energy. Rest mass energy, and the energy can be write down as a square root in m square c to the 4 plus p square c square. So when there is no momentum case, and only the rest mass energy mc square, that is a very well-known equation. And also, so because mc square is the very high energy comparing to the momentum. So, and when we make that expansion like mc square, then it is that the square root 1 plus p over mc to the square. So, and when we make expansion, Taylor expansion, mc square and 1 plus 1 half p square minus and 3 factorial and 2 factorial, 2 factorial to the p over mc square, like that, to the 4, like this. And so from here, and it can be write down mc square plus p square over 2m minus p to the 4 over 8 m cube c square, m cube c square, like this. And here, and the mc square is the rest mass energy, and p square over 2m, it is kinetic energy. So it is a relativistic correction. The higher order term can be ignored. So, and here it is relativistic correction. But we should know that it is minus value. It means that binding energy. relativistic effect can make a binding energy. So, and this relativistic Hamiltonian is very small comparing to the original Hamiltonian, because original kinetic energy, because it is order of alpha to the 4, and it is order of alpha square. So, and momentum is proportional to the fine structure constant. So, and the alpha value is that 1 over 137. So, and it is very small comparing to the original kinetic energy. Basically, I do not prove, but here it is it is known that p to the 4 is commute to the L square, and as well as the Lg, and it is commute with each other. So, and let's think about that first order perturbation. It is relativistic Hamiltonian, and the first order energy is that the relativistic first order is that this relativistic Hamiltonian can be expected NLM basis H prime NLM. Then it is that the minus 1 over 8 m cube c square and NLM p to the 4 NLM. And how to calculate this p to the 4 expectation value? Then let's use that the original Hamiltonian. And basically, then because we already know that unperturbed Hamiltonian can be well defined by the En0. So H0 is that the p square over 2m minus E square over 4 pi epsilon 0 r. So here it is, this term contains to the p square. So when you make that the p square can be write down H0 plus E square over 4 pi epsilon 0 r, and multiply and 2m, that is p square. So, and here we should calculate this term. Let's see that here star. Then the star is that here NLM p to the 4, NLM can be write down as the NLM p square multiply p square NLM. So this kind of p square is a double multiply with each other. So, and here it is case 4m square and NLM H0 plus E square over 4 pi epsilon 0 r, and H0 plus E square over 4 pi epsilon 0 r, and NLM, like this. Because this H0 apply to this NLM, then you can make a En0, and the H0 apply to the NLM, then the E also makes that the En0. So it can make that estimate that H0 becomes En0. So when we expand it like this, 4m square, and because En0 is not the is the value, not the operator, so En0 square, and just only here the operator is applied to the 1 over r. 1 over r is just operator. Other terms other notations are constant. So it is that here en0 to the square plus 2 en0 e square over 4 pi epsilon 0, but r is operator, so 1 over r for the relativistic expectation should be considered, and the plus e square over 4 pi epsilon 0 to the square, and 1 over r square also should be calculated. So, and here, and from this, and we should calculate for this expectation here r 1 over r and 1 over r square. But from the hydrogen atom case, this calculation already calculated, so there is a textbook solution. But here, when you review this, it is 1 over r. It is case, and the integration from the 0 to infinity, and 1 over r and l square r and r square dr. Then the result is that 1 over n square a0. A0 is a Bohr radius. And also here 1 over r square for the relativistic case is the integration from 0 to infinity 1 over r square r and l square r and the r square dr. Then the result is that l plus 1/2 and the n cube a0 square. Then when you using this, when you using these equations, and the en0 can be write down like this, and here, because what about 8m square, but here 4m square, and cancel with each other, so therefore E relativistic first order is that minus 1 over 2mc square, and also en0 square plus 2 en0 e square over 4 pi epsilon 0, and also it is 1 over n square a0, and plus e square over 4 pi epsilon 0 to the square, and also l plus 1/2 and cube a0 square. So, and here, because we already know that en0 is that minus 1 over n square and the e square over 2 4 pi epsilon 0 a0, then it is minus 1 over 2n square mc square alpha square. From these two relations, then we can make that e square over 4 pi epsilon 0 can be correspond to the a0 mc square alpha square. So this relativistic first order is that minus 1 over 2mc square, and it is en0 square makes that 1 over 4n to the 4 m square c to the 4 alpha to the 4, and also second term en0 here minus 1 over n square mc square alpha square, And also here epsilon square over 4 pi epsilon 0 corresponds to this. So it is A0 mc square alpha square, and also 1 over n square A0, and plus, and this term is this one. So A0 mc square alpha square to the square, and 1 over L plus 1 half n to the cube A0 square. So when you see this in the here m square c to the 4 alpha to the 4, m square c to the 4 alpha to the 4, and also m square c to the 4 alpha to the 4 commonly observed, and the A0 cancel with each other, and also A0 cancel with each other. So, and then you can write down m square c to the 4 alpha minus 1 half alpha to the 4 mc square, then first term 1 over 4 n to the 4 minus 1 over n square, and plus L plus 1 half n to the cube. So finally this can be write down minus 1 half alpha to the 4 mc square, and it is 1 over L plus 1 half n to the cube minus 3 over 4 n to the 4. That is relativistic first order energy.